All right, we're in section 10.4 where we're going to use inscribed angles and polygons. So, starters, we have some definitions that we're going to look at. First one is called an inscribed angle. So, an inscribed angle is an angle whose vertex points is on the circle and whose sides contain chords of the circle. So they're all points, all of the vertices are on the circle, and then there are chords that connect it to make the angles. Next we have it says intercepted arc, which is an arc that lies in the interior of an inscribed angle and has endpoints on the angle. An inscribed polygon is a polygon whose vertices lie on the circle, and a circumscribed circle is a circle that contains the vertices of an inscribed polygon. Okay, so looking at some theorems that are going to help us solve some problems. First one here says to be able to measure an inscribed angle. So the inscribed angle theorem states that the measurement of an inscribed angle is 1/2 the measure of its intercepted arc. So we have this angle here, angle ADB. It is intercepted by this arc right here, AB. So why is that useful? It's telling us that whatever this arc measure is, so let's just say it was 100 degrees, for instance, the angle that's inscribed is just going to be half the measurement. So this would then be 50 degrees. Okay. So looking at this diagram here, we have circle P, and then they want us to find these different indicated measurements. So first things first, they're looking at the measurement of angle S, which is right here. Well, we know that the intercepted arc is 60 degrees, so we know that it's going to be half the measure of arc RT, so we know that it's going to be 1/2 of 60, which gives us 30 degrees for angle S. Over here, it says they want you to find the arc measure of QS. So we have the inscribed angle, which was QRS, which was 37 degrees. So that comes from the measurement of angle R. Well, we know that angle R is 37 degrees, so we just multiply it by 2. So 2 times 37 is 74 degrees. Now, below here it says the measurement of RQS is a semicircle, which means that if you wanted to find the arc measure of RQ, you'd simply just take 180 and subtract it by whatever the measurement of QS is, which we know that QS is 74. So to find the measurement of RQ, we just take 180 minus 74, which gives us 106 degrees. This theorem states that if you have two inscribed angles that intercept at the same arc, then the angles are congruent. So here it says that angle ADB, which is in the black segments, is congruent to angle ACB, and that's represented in the blue segment. So what they're saying is, yes, the angles have that different uh, endpoints with C and D, but as long as they both started with A and ended with B or vice versa, we can then say that those two angles are going to be congruent. So here it says name the two pair of congruent angles in the figure. So what we can say is this. Notice that angle, I'll even draw it out. So it says PRQ, so I got PRQ right here, and PSQ, which would be right here. They intersect at the same arc. So we can now say that angle PSQ is congruent to angle PRQ because of that theorem. Also, what else can we find? Well, we also see that angle SQR and SPR intersect the same arc, so same idea. We can say that angle SPR is congruent to angle SQR. Over here it says they wanted you to find the indicated measurement. So they're telling you that this arc measure is 100 degrees. GHF is that inscribed angle, so it's half that, so it's going to be 50 degrees. Over here, they want you to find CD. It's going to be twice as much as that inscribed angle, so it's going to be 80 degrees. Over here, they want you to find RTS. Well, RQS and RTS are, in fact, um, intercepted at the same arc. So because of that theorem 10.8, we can also say that this angle is also 31 degrees. We have a theorem here, 10.9, which states that if a right angle is inscribed in a circle, then the hypotenuse is the diameter of the circle. All right, and they also give us a converse of this. If one side of an inscribed triangle is a diameter, then the triangle is a right angle and the opposite side of the diameter is the right angle. So they say here that if, so it says the measurement of ABC is 90 degrees if and only if AC is the diameter of that circle. We have another theorem that talks about a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So what they're saying is D, E, F, G lie in circle C if and only if D plus F is equal to E plus G, which equals 180. So they always have to be supplementary. So how does that help us and how does that apply to help us answer some questions? Well, they want us to find the value of each variable. So we have X and we have Y. Well, these are two inscribed quadrilaterals, which means that X is going to be supplementary with 88. So X is just going to be added to 88 will equal 180, and Y plus 100 will equal 180. So X will equal 92, and Y is going to equal 80. I go over here and J and L will be supplementary and K and M are also going to be supplementary. So I could say that 8x plus 4y equals 180. And I could also say that 3y plus 3y is going to be equal to 180. So I just have to solve for the variable, I don't have to solve for the angles. So with this one here, combine like terms, I get 12x equals 180, divide everything by 12x equals 15. I go over here, this gives me 6y equals 180, divide everything by 6, y equals 30. If they asked you what are those angles, just plug them back uh, into the expression and go ahead and solve. Over here it says a right triangle is inscribed in a circle. The radius of the circle is 5.6 centimeters. What is the length of the hypotenuse of the right triangle? Well, what we can say here is since the hypotenuse is the diameter and the diameter is twice as big as the radius, we could just say 2 times the radius. Well, they told us the radius, and that was 5.6. So we can say that 2 times the radius is going to be the length of the hypotenuse. So we can say the hypotenuse is 2 times 5.6, which gives us a value of 11.2 centimeters. Okay. And finally here, they want you to find the values of A and B. So to find, let's look like finding B. We just know that they're going to be supplementary. So 4B plus 96 equals 180. Subtract 96, so I got 4B is equal to 84. Divide everything by 4, B equals 21. To find A, I go here. Well, this is a right angle. Some of the means are 90, so it's going to be 5A plus 90 is equal to 180. Divide, or not divide, subtract 90. So I got 5A is equal to 90. Divide 5 to both sides. A will then equal 18. And that is being able to use inscribed angles and polygons. Hope this helps. Until next time.